Welcome to AutoNerf, the automatically firing and aiming Nerf gun. Iteration 1, the laser cut model. The laser cut model was CADed with Tinkercad, and because it was laser cut, the CAD was done primarily in 2D. The main problem with the laser cut model was friction in wood, as shown in this demo. It moves pretty slowly and
That's
unreliably
all we
in
need.
both directions, mainly due to friction.
I think it's literally because of this. I think because of like the surface we're using.
This is the smoothest one I could find though. You can maybe sand it down.
Because of that problem, I decided to move to a 3D printed model. In this model, I made 2 gears, the 2-to-1 ratio, and I superimposed the Nerf gun holder onto the larger gear, very similar to the laser cut model. This is the actual thing 3D printed. And for this iteration, my main goal was to actually make the gun auto-aim towards a target. Over here we have my friend helping me test this out. I'm holding the motor.
No way.
And the gun auto-aims, but then
Okay, it's a little off, but let it guess back.
overcompensates and goes too far. This is primarily due to the processing power of the Raspberry Pi and the fact that it takes a while for it to process the image and actually pass it through the CFI model. So to counteract this, I pretty much made the program pause after turning the motor for a longer time. With 1.5 seconds, it was able to accurately target towards the center mass of the target, as can be seen in this video.
Dude. I'll try to trick it. Oh, that's cool. This is good. This is fucking sick. This is nice.
It's perfect.
That's literally amazing.
Oh my god, we did it.
Holy shit.
We made a self-aiming Nerf gun. Holy shit.
Yes. Let's go. Dude, this is amazing. This is amazing.
Now,
Literally,
let's make a self-firing Nerf gun.
Oh yeah.
I'm gonna kill myself.
Stage 1 done though. Stage 1 done.
Stage one
Stage
done.
1 done.
For the final iteration of the gun, because my friend had broken the previous 3D print, we had to 3D print a new one. This gave us a chance to actually recreate the 3D print into a much better shape with the lessons we learned. This time I used SolidWorks for the blue part, curving the edges so that it would have further integrity with the strength it had. I had to use 3 gears this time so that so that one of the gears would pass under the blue part, so that the motor could still be attached to one of the gears. And axles were also printed so that the motors would spin more smoothly. And yeah, this is us picking up the part. And this is the final project. I also had to build a motor holder out of wood that would actually hold the motor in place. And for the trigger functionality, instead of actually pulling the trigger, because that requires us to go against springs, I instead took apart the gun a bit and used a servo that would actually push the bullets into the motor. And yeah, you can hear the servo going off after it automatically loads. So this is iteration 1. So now we get to one of the main problems I had was gun jamming. As you can see here, the bullet gets jammed into the motor. So the best way to counteract this was to supply a higher voltage to the gun's motor. This way, even when it got stuck after a couple of tries, as you can see, and it hits out. And yeah, so this brought us to the final product where it actually automatically finds and gets down and targets, even after they're dead, continues hunting. Onto the actual circuit. So this is a motor H bridge controlling the rotation motor. The actual main player here is a full wave rectifier converting the 9 volts AC to a DC power supply. and then the MOSFET transistor, which actually turns on the gun's motor when it detects an object. The Raspberry Pi, which houses the object detection code, detecting people, and the Arduino, which actually powers the motors, and of course the crimping, which gets it to the power supply. And yeah, these are some fails. The gun here missed because I foolishly did not account for spin after jamming.
I'm done. This video's over. Why?
And this is me being bad with solder. Yeah, disclaimer, that's not how you tell if something's hot.